For my term presentation, I chose to use NTOP-NG, which stands for NTOP Next Generation, a network monitoring tool. Little info about NTOP. NTOP-NG was created by ntop.org and works with NTOP. NTOP got their name from the Unix command top, which monitors the current processes running on a system. NTOP created many networking tools that handle functions such as packet capturing, which their software is PF-Ring, traffic recording, and box recorder, network probe, and then traffic analysis, NTOP-NG. About NTOP-NG. NTOP-NG is the next generation of NTOP. It runs on top of NTOP. It is compatible with Mac, OS X, Windows, and most Linux distributions. What it does, it's a network traffic probe that shows the network usage. There's two different types of modes, interactive mode and web mode. For interactive mode, it interacts with the user's command line interface. For my example, I'm using two different types of Linux distributions, Ubuntu and SLES11, so I'll be using terminal. So in interactive mode, it's almost like Wireshark, where you can capture packets, you can search, filter, and collect certain packets. One of the neatest features of NTOP-NG is their web mode. So in order to launch web mode, you have to fire up a terminal session and then start the NTOP-NG services. This is better for the non-technical users because it's a GUI interface rather than a CLI. So when you start these services, web mode acts as a web server. Users can log in through a web portal. There's user accounts and privileges and all that jazz. But it's limited to what it can do versus the CLI. So what the web mode does is NTOP-NG is running in the background, collecting all the data, and then it dumps it all into the web interface. So what web mode does, it provides many tools for analysis of the collected network information. This information is collected through the process running in your terminal, and then it's dumped once again into your web browser. As I said before, it's good for non-technical users. One of the coolest features of the web mode is flows. And looking at the picture, it's showing all the active flows, which are like connections and applications that are currently running on the network. Installation. For my example, I installed NTOP-NG on a Ubuntu virtual machine. So I started out on my SLES11 virtual machine and I was having trouble installing it, but NTOP stated that it should run on most distributions, so I just booted up an Ubuntu virtual machine real quick. So my virtual machine platforms parallels was running Ubuntu version 16.10 and NTOP-NG version 2.3.1. So there's two ways to install NTOP-NG. You can go to their website ntop.org and then navigate to downloads and then download their installer. I was having trouble running the installer on my Ubuntu, so I went with option 2 and manually installed NTOP-NG through terminal. It wasn't that bad, so before I go into my demo, I want to lay out a little bit of information that I needed in order to run the demo. So my environment's virtual, so I have two virtual machines. One running Ubuntu, which is Ubuntu 101MP. That one has NTOP-NG installed. Its IP is .8 DHCP. Then my second virtual machine is SLES11VM, just another host on the network. So we can do a couple things during the demo, and its IP address is .6. Now I'm going to do a little demo of how to use NTOP-NG. So once you fire up the services on terminal, you can open up a web browser and in the URL type your servers or VM name, :3000 and hit enter. When you come here, you'll be taken to the web portal. It comes with the default username and password. Once you can actually change that after you log in. So we're logging in now. As I said earlier, there's user accounts you could use and manage with preferences. So it comes with the default username and password. You can change that here by managing. You can create more accounts for different users. Um, Next, show how it masks the networks and how it groups all the stuff. So if we go to hosts and networks, it can show us all the hosts that are currently on our network. This is our internal network used by Parallels. So as you can see here, there is currently 2 hosts, which is the gateway and then the host world right now, 10.211.55.8, which is the Ubuntu, which is running on top. If you click it, it shows some generic info about the actual host. It shows what the operating system is using. It shows the MAC address. It shows how much all the activity that's going on, and it also shows what the network looks like right now. So right now nothing's really going on, so we're not getting any bits per second. But since we have another virtual machine, we can SSH to that, and then we can create some network traffic. So right now I'm logged into there, and now we are going to ping the host, the VM that's running Ubuntu. So right now I'm SSH'd into the /11 machine, which is just like another host on the network. So if we ping that, we'll see that we get acknowledgement, and then if we go open up another terminal, we could do a TCP dump to make sure we're getting it all. Grep for our the /11's MAC address. With the sudo. So it'll take a couple seconds, and then we'll see that we're getting acknowledgements on the other side, as you can see there. And then if we go over here, almost instantaneously, we'll see a little bit of network, because pinging doesn't cause that much network traffic in general, so we can see that it actually moved a little bit from 0 to 12 kilobits per second. Now if we go back to host, we can see there goes our host right there, the /11 machine. Now it's coming up on the network. Next thing I want to show is flows, which is it's like an analysis tools they use, and so this is sort of like Wireshark, where you can filter by packets and protocols and all that. So you see what's going on in the network. So when we click flows, we get shown the active flows. So right now we have SSH, which is how we're connecting to this /11 machine, and then a couple other things. So right now we still got that TCP dump going on with the ping, so we still got some network traffic. So I want to show what happens when we download something and how we can use this tool effectively. So we go to software.drexel.edu. It's going to open up an SSL, and we'll actually see that here. We refresh this, and it pops up. We refresh this. You see multiple things have just came because we're actually using the network instead of just internal. So we have DNS, which is how we got the software.drexel.edu. Then we have our SSL, is how we signed into software.drexel.edu. So now we can actually download something. So if we go here and then download anything like Acrobat, if we save it, so it's downloading right now, and then You give this, you can actually see the spike instantaneously of network traffic. So it went from like 10 kilobits per second to an average of about 20 megabytes per second because of the caused by the download. You can use this because if we're on a network, we can see all the protocols that are going on. So, say we have like the SSH, we can see who's connecting to who, and then what's causing all the network traffic going on. So you can see and then if we want to sort by like, see all the hosts that are using SSL, if we click the actual link here, it'll show us all the hosts that are using SSL protocol.